Hello everyone, welcome to this lecture of the course Digital Signal Processing. In the basic course of Signals and Systems, we have seen an important transform known as Laplace transform, and since the beginning of this course we are focusing on Z-transform. Let us have a comparative study for both these transforms. Now the basic difference between these two transforms is that the Laplace transform is for continuous time signals, whereas the Z transform is for discrete time signals. Now if we look at the mathematical definitions for both these transforms, the Laplace transform of a continuous time signal x of t can be calculated using the formula x of s is equal to integral from minus infinity to infinity x of t into e to the power minus st dt. And the Z transform can be calculated as x of z is equal to summation n running from minus infinity to infinity x of n into z to the power minus n. The inverse Laplace transform can be calculated as x of t is equal to 1 over 2 pi j into integral from sigma minus j infinity to sigma plus j infinity x of s into e to the power st ds. And the inverse Z transform is calculated as x of n is equal to 1 upon 2 pi j into integral over a contour c x of z into z to the power n minus 1 dz. Now this factor s is given as sigma plus j omega, where this sigma is the attenuation factor and this omega is angular frequency. And the range of this angular frequency omega is all the way from minus infinity to infinity. And if we look at this term z, it is given as z equal to r into e to the power j omega, where again this omega is the angular frequency but with a limited range of omega belonging to minus pi to pi. And this r is magnitude of z, that is distance from origin to z in z plane. Now if we look at the shape of the ROC, the region of convergence for the Laplace transform is in the form of the ROC is in the form of parallel strips that are parallel to j omega axis. And the shape of the ROC for Z transform is of annular ring, annular or circular ring. Now for the Laplace transform, the ROC for a right-handed signal is rightwards to the rightmost pole. Whereas for Z transform, the ROC for a right hand sided signal is outwards or exterior to the outermost pole. Similarly, for left hand sided signal, the ROC is leftwards to the leftmost pole. And in the case of Z transform, for left hand sided signal, ROC is interior to the innermost pole. Now, in the Laplace transform, if the ROC or the region of convergence includes j omega axis, this indicates that the Fourier transform for that particular signal exists. Whereas in case of Z transform, if the region of convergence includes unit circle, it indicates that Fourier transform exists. Let us try to analyze this graphically. Now this is a typical Laplace plane or S-plane, and this is a typical Z-plane. Now this is the imaginary axis of S, that is imaginary of S, j times imaginary of S, that is j omega axis, and this is imaginary of Z or j times imaginary of Z, and here it is sigma, that is the attenuation factor, and this is the real part of Z. Now this is the unit circle. Now the last comment which we had made was that if the region of convergence for a Laplace plane or the S-plane includes this j omega axis, then the Fourier transform exists. And in the case of Z transform, if the region of convergence includes this unit circle, then the Fourier transform exists. So if we have some kind of equivalence in these two planes, we can say that the j omega axis in the S plane is equivalent to the unit circle in the Z plane. Similarly, we have commented that the region of convergence for a right hand sided signal is rightwards to the rightmost pole. So if we have the poles on the j omega axis, or if we consider the j omega axis as the reference, then this right hand side plane will be mapped to the exterior part of this unit circle. As if we consider the unit circle as a reference point, then for a right hand sided signal it would be exterior to the unit circle. Hence this right hand side plane will be mapped to the exterior of the circle. Let's write that. The right hand plane of S-plane will be mapped to exterior of unit circle of Z-plane. Similarly, the left hand side or the left hand plane of this S-plane will be mapped to the interior of the unit circle. So the left hand plane of Laplace plane will be mapped to interior of unit circle of Z-plane. So in this video we have seen the comparison between two interesting transforms, that is the Laplace transform and the Z-transform, and we have also seen the equivalence between the S-plane and the Z-plane. So let's stop here. Thank you.